Welcome back. This is the third lesson recording for day 8. We're going to do a couple of examples and we're done. Okay, so now we're going to try to find 6th root of this complex number written in polar form. So 64 cis 12 degrees. Okay, so the first thing you should recognize is that we are looking for 6th root. That means we are looking for 64 cis 12 degrees. We are taking it to the 6th root. Okay, since we're taking 6th root, how many answers are we going to get? We're going to get 6 answers. Okay, so if I go back to the formula here, okay, this was the formula and this is my modified form, right? So when I am taking the nth root, I need to take nth root of the modulus, and then I need to divide the angle in polar form, divide by n. So the number of, in this case, we're taking 6th root, so this will be 6. And then 2 pi, instead of 2 pi, we can think of it as 360 degree multiplied by k divided by 3. So the form, this just becomes, all right, so we have to take 64 to the power of 1/6. Okay, and then we have to get, welcome back. This is the third lesson recording for day 8. We're going to do a couple of examples and then we're done. So the first example says to find the 6th root of 64 cis 12 degrees. So this is a complex number already in polar form. That makes it easy for us. So what we are looking for is, we're looking for 64 cis 12 degrees, and we're looking to take 6th root of it and trying to find the values for this. And the solutions will be complex numbers, right? And since we have 6th root, that means we are going to get 6 answers. So let's go back to our previous part, okay, where we've modified the formula. Okay, so here, this is the formula, and we've actually separated this. So when you're taking the nth root of a complex number in polar form, for the modulus, you are going to take nth root of that modulus, or the radius, right? And then for the angle, you're going to divide that by however many nth root you're taking. So in this case, since we're taking 6th root, n will be 6. Then instead of 2 pi, we can use 360 degrees times k divided by n is 3 again. So we're separating it. So what you're essentially doing is, first, I need to deal with the modulus. Okay, so 64, if I take 6th root of 64, that means what is the number that multiplies to itself 4 times? That gives 64, and that is going to be 2. Because 2 times 2 times 2 times 2 times 2 times 2 is 64. All right, then to find the angle, what I'm going to do is I'm going to start at the angle right here. That's 12 degrees divided by n. So it's going to be, what I am doing is theta divided by n, and theta in this case is 12 degrees divided by n. N is 6 because we're taking 6th root. And so 12 degrees divided by 6 is 2 degrees. So what you are saying is I am starting with 2 degrees. My first solution is going to be 2 is my modulus, and then cis cosine of 2 degrees plus I sine of 2 degrees. So I can write that in shorthand like this. This is my very first solution. Okay, and then from here I am going to be adding. Okay, the adding part is going to be here this was what we're starting with. When k is equal to 0, you're just left with this. That's why the first solution was beta divided by n. So now k is equal to 1. So you're 360 divided by 6. So you are going to be dividing 360 divided by n. In this case, 360, n is 6, so 60 degrees. So you are going to be adding 60 degrees to the first solution. Okay, so 60 degrees plus 2 degrees is going to be 62 degrees. And the modulus is going to be the same. And then the third solution is going to be 6. Another 60 degrees gets added. That's 122 degrees. And then fourth answer is 6. Another 60 degrees. That's going to be 182 degrees. Remember, we should be getting 6 solutions because we're taking 6th root. So 60 plus 182 is 242. And then finally 2, 6, 302 degrees. So here are my 6 solutions. Okay, 6 solutions that if I raise this to the power of 6, is going to be equal to that. And since I started with the polar form, I can leave the answer in polar form as well. That's allowed. Okay, unless I specify that we want the final answer to be in rectangular form. Now we're going to try a different problem. This time, find the fourth roots of this complex number, -1 minus 2i. Now this time, this complex number is in rectangular form, right? So we first need to convert it to polar form. So convert to polar form. Now how do I do that? Well, I first want to do a quick sketch to make sure that I am aware of which quadrant this complex number goes in. This is my real axis, and this is my imaginary. And -1, the real is going to be somewhere like here. -2i is going to be maybe -2i here. Okay, so we're dealing with a third quadrant. Okay. Now, in order to convert it into polar form, we need to find the modulus or the radius. Is going to be a square root of a squared minus plus b squared. So -1 squared is going to be a squared plus b squared. So that's going to be square root of -1 all squared plus -2 all squared. And that is 1 plus 4, which is 5. So square root of 5. The modulus is going to be square root of 5. What about the angle measure? Well, this is the angle that we're interested in. And this is actually the reference angle as well. Okay, so the angle is going to be, in this case, this is -1 here. And this is -2. Okay, so this vertical. Okay, so tangent of beta is going to be b over a, so that's -2 over -1. Or tangent of beta is going to be -2 divided by -1 is just +2. So that's going to be beta is going to be inverse tangent of 2. And if I use the calculator, it's going to give me 63.435 degrees. Okay. However, what the calculator has given me is quadrant 1 angle right there. This is the angle that it just gave me because inverse tangent is defined for quadrant 1 and quadrant 4 only. So that means I need to add to this, I need to add 180 degrees. So I know that theta is going to be 243.435 5 degrees. Okay, now, so my polar form is going to be square root of 5 is 243.435 degrees. And this is my polar form. Okay, so then from here, we're going to use the formula. Okay, so this is my step 2. Now, the formula says with the modulus, you need to take the nth root. So in this case, we are taking 4th root. That means the modulus is root 5. And we're taking 4th root of that. Okay, so this square root of 5 is really same as 5 to the power of half, right? And you're also taking the 4th root of that is like taking a 4th root of that itself, which is same as 5 to the power of 1/8. Or we can write it as 5 to the 8th root. Okay, what about theta? Well, to find theta, you start with theta over n. So theta right now is 243.435 degrees. So theta is 243.435 degrees. And now, and we're taking nth root. So we're taking 4th root. So n is going to be 4 divided by 4. If I divide that angle by 4, I get 60.859 degrees. So this is the angle that you're going to be starting with. So start with, okay, so that means my very first solution is going to be modulus is root 5, 8th root of 5, and it's going to be 60.859 degrees. That's my very first solution. And then what is my second solution going to be? Second solution is going to be where I am adding 360 divided by n. So then we're going to be adding 360 divided by n. So 360 divided by n is 4. So we're adding 90 degrees. Okay, so we're adding 90 degrees to 60.859. So my next solution is going to be 8th root of 5 is 90 plus 60 degrees, 150.859. And then the next solution is 8th root of 5 and 6. Another 90 degrees needs to be added, 240 degrees, 859. And remember, because we are looking for 4th root, we should have 4 solutions. So here, it's going to be 6. Okay, another 90 degrees added to this is going to be 330 degrees, 0.859 degrees. Now this is in polar form. We want to convert this into rectangular form. How do I do that? I would just need to, this is equivalent to 8th root cosine of 60.859 degrees plus I sine of 60.859 degrees. So you just multiply this using the calculator. So you are doing cosine of this angle here, and then multiply that by 8th root of 5. And when I do that, I actually get 0.595. And when I multiply this number to sine of this number, this angle, I get plus 1.0681 I. So that's going to be my rectangular form of the first solution. And if I do the same thing with my second solution, you are just distributing this to the cosine and I sine, you get -1 plus 0.068 plus 0.595 I. And the third solution is -0.595 minus 1.068 I, and last